Hey everyone, so today I have someone from NYU. So he graduated 2 years ago. And yeah, do you want to give a quick introduction on yourself and then also a little bit about how many lead code questions you did?
Yeah, so I graduated from NYU like a few years ago. Been
Mm-hmm.
working for 2 years. I've been recently getting back to lead code. Yeah, trying to get into like a FAANG adjacent company.
Yeah,
So yeah, that's like my goal. I've done around I mean in total probably like 200-ish, but
I see.
it's kind of like a off and on process. Yeah, but I've been more consistent lately for sure.
Yeah.
Yeah.
How has the job hunt been for you since I mean you went to a really good school, you already have some work experience. Is it still rough or no? Like getting interviews.
Uh, yeah, I think it's still pretty rough. Yeah.
Like you're not getting any calls at all, even from like
Um,
non-fan companies, startups and stuff.
I feel like no, no, there's definitely some like recruiter like emails or calls, but like they don't land much into like the later
Hmm.
stages of like interviews. Yeah.
Okay. So what's kind of your strategy for getting into Fang?
Oh, yeah, just gonna grind my lead code, grind my. So I also want to get into like studying for system design. I haven't started on that yet, so
Okay.
that is definitely on my list. But for now, I'm trying to get really comfortable with lead code
Nice.
first. Yeah.
So get comfortable. Get ready. I mean, but like, how are you gonna land the interview? What's your plan there?
Oh yeah. Yeah, I think I have to like do more impactful personal projects, not gonna lie. So like my resume, it could be better. Like I at first I thought like with like some job experience it'd be easier, but doesn't seem like the case. Yeah, so I'm gonna do more like impactful projects, and like just like clean up my resume in general. Yeah.
Yeah. I mean, honestly, you're at the 2 year mark, and 2 year mark is good, but it's in a weird state where
Yeah.
you're just almost past being a new grad for some companies, because usually in most companies you or they're looking to hire intermediates, and usually they have like 3 to 4 years of experience. So
Yeah.
and then usually for senior you need 5 plus experience to get hired. So I think you're almost at that phase. Because I remember I started applying when I had only 2 years experience. I wasn't getting that many interviews, but once I hit three, I started getting a lot of interviews for intermediate positions. So it's kind of like in a you'd still get some, but it's a little early. But yeah, so let me think. You've done 300 questions. How comfortable are you with lead code? Can I ask you hard questions, easy questions?
Um,
Just
yeah, I don't
avoid
think I'd be
DP
able
or
to do
whatever.
hard.
Okay.
Yeah, so I actually no DP yet. Yeah, I haven't studied too much DP, but everything else I think should be fine. Yeah.
Were you the one who recommended do cousins too or something like that?
Uh, no.
You ever done that question? Okay.
Mm, yeah.
Okay. What
We doing
programming
that one?
language? Yeah. What programming language do you want
Okay.
to code in?
Python. Yeah.
Okay. All right. Let me see. Let me give you a nice question to start it off with.
All right.
Let me sec.
Low key, getting kind of nervous here. Just like a real interview.
Let me give you a good. All right. Let's go with this one.
All right.
So we're pretty much given the root of a binary tree. We need to replace the value of each node in the tree with the sum of all of its cousin values. Two nodes of a binary tree are cousins if they have the same depth with different parents. So return the root of the modified binary tree.
Okay. Let me read it again. Okay, I see.
Yeah, and we could work through some examples. Like, I'll let you go and drive that aspect, like
Yeah,
clarifying it.
replace the tree. Yeah, so are we always given like a non-empty tree or yeah, can we assume that?
Yeah, but we always given one node.
Okay, I see. Yeah, let me try to write up a quick example. So for this tree here, so these two nodes would not be cousin because they have the same parents, right, on
Yep.
this level. But on level 3, let's see. So so nodes 4, 5 are cousin to 6, 7 because they have different parents,
Yeah.
but they're siblings
Yeah.
of each
So
other. Okay.
four's cousin is 6 and 7. Five's cousin is six
Okay.
and seven. Six cousin is 4 and 5. Seven cousin, yeah.
Yeah. Okay. Sorry. So we're gonna want to replace 4 with so we're gonna want to replace 4 and 5 with 13. So that's 6 plus 7. And then we're gonna want to replace 6 and 7 with 9, right? Uh, 13, 13. So I think this is gonna be the modified tree that we get. Yeah. Okay.
Oh wait,
So
don't modify the input for now,
oh, okay, yeah, sorry.
so we can verify.
Oh yeah, we kind of lost a reference there. 4, 5. Yeah, 6, 7. Just gonna start a new line here. Yeah, so 4 and 5, the new value is gonna be 13. And then 6 and 7, the new value is gonna be 9. Because these two nodes are the cousin of these nodes, and we just wanna replace the values of the nodes or the cousins. Okay. Yeah. So I think, yeah, first thing come to mind is we have to run some kind of BFS because just like a naturally good way to calculate
Hmm.
values like level by level.
Wait, what would the output be here? One, two,
Oh yeah, it's gonna be like
three.
1, 2, 3, and then 13, 13, and then 9, 9. Yeah. Yeah. Does that look good to you?
Yep.
Okay, yeah. Yeah, so I think we want to run some kind of BFS. And we also want to keep track of the parent when we are processing the nodes. So we know like which cousins in the same which node in the level are like cousin or siblings to each other. So we don't so we can calculate it properly later on.
Mm-hmm.
Um, yeah, let's see. So yeah, so going back to the original example, so in here we begin a BFS process, we pass in 1, and then we will queue in 2 and 3. So 2 and 3, we see that they have the same parent of 1, so we don't modify their value, and we begin killing their neighbor again. So we get to 4 and 5. Um, yeah, so these two nodes. So here we'll see that 4, 5, 6, 7. Okay, I see. Okay, so once we are at a level, um, we would want to keep track of all the nodes with the same parent, and then we want to sum up the values of the nodes that have other parents, if that makes sense. And then we, yeah, replace it later on.
Okay.
Yeah. So yeah, 1, 2. Yeah, like we wouldn't want to like replace it immediately because we're gonna lose like the original value. So I think we're gonna do the calculations and then we're gonna replace every node in the level at last.
Pretend we had something like this: one, 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 one.
Mm,
Let's space this out a little bit.
yeah.
Like basically, what I'm saying is, how am I gonna add up efficiently all of the cousin values? Like if I'm looking at this one, or pretend I'm looking at this one.
All right.
If I'm looking at this one right here, how I'm gonna add up all the ones beneath it, or all the cousins efficiently. Because even if,
Yeah.
because it could just be like a, I mean, we could do like for each one a double for loop or something. Like for this one, look at all these ones. Then for this one, look at all of them again, except for the cousins. Is that what you're thinking?
Um, no, I was kind of thinking like, um, so when we at this level, like
Mm-hmm.
we kind of keep track of all the parents and then we s- we sum them up and then we see that and then for each of the node we just calculate like the sum of all the other nodes that don't have the same parents.
But how do we do that part? That part that you're talking about.
Yeah. Yeah, one yeah, I feel like we should do some pre-processing maybe. If we run like a BFS one time and then we capture the sum first and then we run it again.
So do a BFS and capture the sum of what?
Yeah, so it's gonna be like you can run a BFS and then so for so for this starting from the second level, we see that the sum is gonna be 5 and then we run it again and then it's gonna be 9. So like the sum here just kind of represents
The sum
like the
here.
sum of yeah, like we're gonna have 9 and then 13. We have 5. So in here we will have like 2 and then 2 and 2.
So we're adding up each sibling.
Yeah, yeah, I guess, yeah, I guess we just want to calculate the total sum of each level, and then, so like at one run, we'll calculate the total sum of each level, and then we just subtract that total sum from like its sibling sum.
Mm-hmm.
Yeah. So that should give you like the cousins for each node. Yeah, so going back, so we're gonna use that approach. So the total sum of here is gonna be 5, and then, but
What about the next row?
yeah, so next row is gonna be 4. So 9 plus 13 is gonna be 22. So it's gonna be 22, and this one I believe is 8. And then in here we can just, so for these two nodes we can, so we would also want to keep track of like a sibling sums. So in here will be 9, and then we do like 22 minus 9, and then we're gonna get 13 for these two.
Okay.
And then we're gonna do 22 minus 13, and then we get like 9 for these two.
Okay.
Yeah. It does that make sense?
Yeah, that makes sense. So
Yeah.
you're gonna perform a BFS at first to capture to capture the total sum at each level, and what are you gonna do to update the tree? Like what algorithm?
Yeah, so I think, so once I do a BFS, let's see, what's like I was just gonna go with another BFS.
Okay.
Yeah, since we're just kind of doing it level by level.
Okay. I think what you said makes sense. Go ahead and implement that.
Okay, yeah. Should I write up the tree node class or?
Yeah.
Okay. And after that, I'm gonna write a function. Let's call it replace node cousin. And then we're gonna take in, the root of the tree. So should, okay. All right. Yeah, so BFS, so we're gonna need a Q, Q, and YOQ. So first we're gonna, yeah, so we're gonna offer the root node to the Q, and then we can up from the Q. And some, yeah, actually I think I would want to make kind of like a sum array to hold the values of each level. So we're gonna pop each node, pop all the nodes from each level, and then add them to the current sum of that level, and
Sure.
then yeah, if we have a left children, we can offer it to the Q. Yeah, so like each for loops is gonna signify like one level. So at the end, we can append the sum of that level. Yeah.
Makes sense.
Yeah, so doing this, we should have the sum array that, so sum array give us total sum of each level. Okay, so now I think we will want to do the actual replacing. Yeah, so I think it's gonna be another BFS. So I think in here we would need to keep track of an extra variable called like parent. Yeah. So we know like, so we know which sum we shouldn't count towards our, like the cousin sums. Yeah,
Okay.
if that makes sense. Yeah.
Yeah, makes sense.
Yeah. So it's kind of the same implementation here. Slightly different. Oh, actually, I think we want to pass in another value. So it's gonna hold like the sum of itself and like all its sibling. So I think that'll be easier for us to calculate it.
So,
Yeah, so like if we go back to this tree, um, so when we are processing 4 and 5, we're gonna do like 9. Yeah, we're gonna do like sorry.
so right here we're looping through the node and we have the parent.
Yeah.
Once we know have the node and the parent, we just need to like we already have the sum right
Yeah.
of that level. We just need to do
Mm-hmm.
that operation you mentioned, which is sum minus or sum of that level minus me minus my sibling.
Mm-hmm. Yeah. Yeah, so we would have to keep track of a sum that's like this of nodes that have the same parent. And we know that it's gonna, since we're doing like a BFS, it's gonna go from like left to right. Um, so maybe we can do like per sibling sum, and then so if the nodes have, so if the nodes that we are currently looking at have the same parent as the last node, then we can add to the sum.
Okay, I want to get
Yeah.
to the second question, so we'll just stop this one here. Let me print in the next question.
Oh, okay.
Yeah, because I want to work to two questions. Let's see.
Yeah.
So around. Let's see. So cool. So this is the next question. We're pretty much given an array of n objects, colored red, white, or blue. We need to sort them in place so that the objects of the same, let's say n numbers, or n object, whatever, n objects called red, white, or blue. Sort them in place so that the objects of the same color are adjacent, with the colors in the order of red, white, and blue. So essentially, I'll show you the examples. Right here. We pretty much just need to sort the array in place. So have the zeros, all the zeros in the left, the ones in the middle, and then the
Mm.
twos all the way on the right.
Mm-hmm. Yeah, we must. Okay, so do in place. So we can make like a new, like kind of like a result array and then just count everything, right? Like, yeah,
Making a
in
result array.
place. Yeah, it's just like a pretty easy solution that comes to mind. It's just
Yeah.
like count how many zero and ones we have and then just append it to
What
like a
would be
new
the time and
array.
space complexity on that?
Yeah, it's gonna have like a linear space and time because we have to make an array to hold all the result, and we have to loop through the array twice.
Okay.
Yeah,
What about
but
space?
it's also gonna be linear because we have to uh, allocate memory for like a new result array.
Okay.
Yeah.
What about can we get it down to O1 space? Cuz yeah, creating a new
Yeah.
array would be easy.
Yeah. So if we want all of one, then we have to do it in place. Okay. Um, so I think since there are only three three possible digits, 0, 1, and 2, we can probably use like 3 pointers to keep track of like where the 0 or the 1 or 2 should go. Because 0, they have to go to like the beginning of the array, and then the 1 will have to go to the middle, and then the 2 will have to go to the end. So I think with some pointers, we can do it in place. Okay. Yeah, so I think we would want some kind of 0 pointer. So in here, gonna have like a 0 pointer, and then we're gonna have like a 2 pointer. So at each iteration of like our loop, we're gonna want to move 0 to where the 0 pointer is pointing to, and then move 2 to where the 2 pointers are pointing to. I don't think we would need another pointer for 1 because the 1 would just go in between the 0 2s. Yeah, so that's like the
Mhm.
general idea that comes to mind. Um, yeah, so let me try to run that approach on this input over here. And we also gonna have like a current pointer. Yeah, so we see that this digit 2 should go to the end of it. So we swap that. Um, so we have, so first iteration, we swap the 2 towards the end. So we're gonna have to move the 2 pointers. And then going back to it, we see that the digit that we have swapped over is a 0. And that is what we want at the 0
Sure.
pointer. So we can also move the 0 pointer. And then we can also move the current pointer. And then we see that it's a 0. That is what we want since it matches up with the 0 pointers. We can move it again. Let me kind of space them out. Yeah, okay, so here we see another mismatch. We will have to swap them over
Yep.
with where 2 pointer is pointing to. Yeah. And then we swap a 1
Oh
over.
wait, go back. Go back.
Oh,
Wait, Command
yeah.
Z. But that's a 2, right? Or how did the two pointer go down?
Oh.
The two pointer was here before, right? I thought. How'd you
Oh,
do?
no. I just kind of spaced them out. It was supposed to be like n minus 1, like n minus 2.
So it's not
Because like
starting
the
at the 2, it's starting at the 1.
no, because previously I already swapped a 2 towards the end, so I already have moved the 2 pointers.
Okay.
Yeah, I just
I
kind
see.
of like
I see.
messed it
Okay.
up the spacing
Okay.
because I spaced
Okay.
them
I
out.
see.
Yeah.
Makes sense. Oh, I see. I see.
Yeah.
Yeah.
Yeah. Yeah, so we see a 2 again. So we want to swap it to where the 2 pointer is. So we swap, and then we move the 2 pointers.
Okay. I think overall it looks promising. Go ahead and implement it.
Yeah. Oh, I was just gonna say, so I think we would want to end the loop when our current pointer like overlap the 2 pointers. So that means like everything should be sorted. Yeah. Sort colors, let's call it. So we don't, okay. So the input is just gonna be like a num array, right? Num array. Do we need to return anything if we're gonna do it in place? I guess we can just
Yeah,
return
return me
nums.
the num so I could verify.
Yeah, sounds good. Yeah, so if we see if nums, so if we see a 0, then we wouldn't, I don't think we would do anything if we see a 0 because that should be in the right place. So if we see a 2, we would have to swap where a current number and the 2 is. Oh, sorry. If we see a 0, we can still do the swap because we have to increment the 0 pointer and keep track of it. And so we're gonna increment, there should be a minus. Yeah. Actually, adding a while loop would be better because I want the condition to be while I doesn't overlap the 0 pointer, the 2 pointer, sorry.
So I incrementing the pointer. If it's 0, swap.
Yeah. Oh shit. Yeah, if it's 0, we will want to swap with the current number with where our 0 should be. Yeah, so the same logic applies to yeah, let's see. Yeah, let me try to dry run the code on some test cases. I guess you ran it here. Can I just since you ran already, can I just kind of
Yeah.
put in some other cases here? Okay.
Yeah, put in some cases.
Yeah. Okay, so this one is not right. I'm gonna try to make it smaller so it's easier to debug under synchrony.
I'll give you this case right here.
Yeah. One zero two. So first we're gonna look at these numbers. So we're gonna swap a
Yo, chat.
one
CJ, like Coding
with a
Jesus did a
two,
review on his code, and it was
and then
bad, really bad. I was looking at it too. I was like,
we're gonna,
that's terrible code.
oh, sorry. We're gonna swap the one with the two. So we would decrement the 2 pointers. Oh, I see. Okay. So with my current code, because I'm gonna increment the I, so the I is gonna be incremented to the 0. And then wow, I is less than. Yeah, because it's the condition would break, so it wouldn't run. Maybe I just add an equal sign.
So it hits the one, and it just skips the one.
Yeah.
What'd you change?
Yeah, I think. Oh, so I added like an equal sign here. Yeah. But I wonder if that's like that will only work with like this specific test case.
Yeah, I think it might break on larger test case.
Yeah. I feel like I'm not correcting the one properly. Um,
Because what happens when you get to the one? What happens?
mhm.
Or sorry, what happens
Like,
when you get to the zero? Okay, you get to the one. That's fine. That's fine. You skip. When you get to
mhm.
zero, or just do a dry run on this small test case. That one worked, but pretend we have. Let me draft one up, or okay, I'll do another one right here. One
So
two
it
zero.
breaks on this one. Yeah, let's see what's happening on this one. Yeah, so we see a one, so we don't do anything. Um, and then and then we move to the two. So we see a two, we swap it with the two. Yeah. Oh, okay. So I guess when we swap, there's like a possibility we swap in like a zero, and then we shouldn't always increment an I pointer. We should recheck what our current index is pointing to. So in case it's a zero, we should move it to the correct position. Yeah, so it's a zero. So when we swap it, wonder does it just cancel? Yeah.
Okay. We only have a couple minutes left, so want to end it here. How do you think you did on the interview?
Oh,
This one's close already, so yeah, we'll just stop it here.
yeah. Yeah, I mean, I would have wanted to be better, but yeah, kind of still getting my groove in. Yeah.
Yeah, let's see. Yeah, I mean, you solved 90% of the question there, but it's just the case. Yeah, like when you for this one, when we have the 1 and 0,
Hmm.
1, 0, and 2. When you swap, you go to 1, or no, it's 1, 2, 0. Right. Or what was the one that broke? It was it 1, 0, 2. Oh no, that
I
worked.
think it's 120. 120. Yeah. Oh wait, what? Oh, maybe because it's my new code. Oh, wait, let me get rid of.
I
Yeah,
minus 1.
yeah.
Yeah, 1, 0, 2. Let's see how that works. Okay, you have the 1. You move
Hmm.
on. So pretty much what happened, right, is you flip the 2 and the 0, so you get the 0 and the 2, and then you would increment, but 0 is not in the right place, so you kind of have to stay on
Yeah,
that
yeah.
same one and then flip the 0 with the 1, and only then you would move over. So it's just like you need to change up this condition just a little bit. I think maybe an if statement here, something like that. But
Yeah. Yeah, I wonder if this will just work, like if I like kind of decrement if I swap a two or something.
I mean, let's
So
try it
like it would
on this
stay
first
on like
one
the correct position.
for 2. Okay, what it feels like 1, 1, and like 2. Yeah. So what does a decrement actually do? Why does it just stay for 2 and not for 0 or something?
Yeah, because I think so when we see a zero, like if what a I pointer is pointing past, like I think zero must be in the right places. Because like if it wasn't in the right places, like let's say like if it's like a two, then we would have swap it towards the end. And then if it's
Yeah.
a zero, we would swap it to where the zero should be. If it's a one, we don't do anything.
Hmm. Okay.
Yeah.
I think overall, like, yeah, it's really close. Yeah, I think what you'd have there might work. I'd have to test it on leak code. Let me just quickly test it. Actually, it's right beside me.
Okay.
Oh, nice. Yeah,
Oh,
that worked.
nice.
Cool. Yeah, you're
Cool.
able to get the question 2. I think for question 1, you clarified it well. You're able to figure out a solution, but it took some time for you to think, and you came up with a good solution, which is just take the sum of calculate the sum of every row using one
Mm.
BFS, and then doing a second pass where you subtract the total sum of that row minus itself and its sibling. But I think you're just
Mm.
having trouble with that second DF or second BFS and just tripping out on the logic there. So you weren't able to actually get it done. So I think just needs more practice to just make sure that you can implement that fast. And it's a slightly different variation of BFS than what you're used to.
Yeah.
which is why I probably tripped you out. So yeah, I would work through that problem, work through variants of BFS to just make sure you iron that out. But I think overall, I mean, the way that you walk through the solution, and I think you're able to dry run the code really well, and then you're able to explain me exactly what you're thinking. So I can, and that's helpful for me because I'm able to find out where you're stuck and give you pointers. But some of the problem solving could just happen a lot faster, and that all just comes from practice. I don't think you have any issues with like the language or working with pointers and everything. You showed you're able to do that, but just getting to the solution faster and implementing it faster with no bugs.
Yeah, for sure.
Cool. All right. Thanks for taking the time out.
All right, thanks, man.
All right. See ya.
Peace.
Peace.